really, Eclipse just did me a favor. I probably would have gone and deleted all that code anyways, knowing me. All right, so I'm going to create a new project again. CSC300 Spring 2015 stack. Fair enough. All right. And we're going to create a class in here. We'll call that guy driver. String array elephant. Make sure everything's firing okay. All right, perfect. All right, so remind me, 3 functions for stack.
Push, pop, peek.
Push, pop, peek. What does push do?
Adds one.
Add something to the top of the stack. What does pop do?
Takes one away.
Takes 1 from the top of the stack. What does peek do?
Use the top.
Lets me see the top, but doesn't actually remove it. Do you usually wear glasses?
No.
Oh, because it doesn't look good.
Okay.
Actually, you look more studious. You kind of usually look kind of stupid. See, that's it. That's right. That's right. You start off with a negative, then you look like oh, I'm just kidding. You actually are usually stupid looking. Now you have to wonder which is true. Worst part is, what if it's neither? What if it's bad both ways?
What if it's good both ways?
No, that's not the case. I can promise you. Christian worldview.
How does that work?
All right. Well, what was the homework?
Glasses given in Christian world?
Oh, write a stack. That's right. See, I've had friends who've told me I should get the LASIK crap. I think I just look ridiculous without glasses on. I mean, that's not right, is it? That's not right.
No.
No, the glasses make the fat nerd complete. Right? It's the whole. All right. So we're going to create a stack. And we're also going to create another class called node. Stack is a collection of nodes. Nodes will have payloads just like they did before. Okay, nodes will also have a next node. We don't need to have a previous node because we're always adding and removing from the front of the stack. That doesn't mean it's wrong to have a previous node, but you would never use a stack that way. One of the benefits of a stack is that it's a simpler version of a linked list. Substantially simpler, actually. All right, and then we'll give ourselves some setters and getters. Source, generate getters and setters. We want set and get for next node, and we just want get for payload. All right, so there's those. Perfect. Go back into stack. We're going to have a private node top for the top of the stack. You could have called yours head if you wanted to, but using the the stack verbiage, the top of the stack would be the first element in the stack. All right, then we'll have our constructor. Takes nothing in as a parameter, and it sets this dot top equal to null. Then we'll have a public void push int payload. We'll say node n is equal to new node, passing it payload, so we have to go write our constructor in node. Public node int payload, this dot payload is equal to payload, this dot next node is equal to null. All right, so there's our node and his constructor. Back to stack. when we first we push a new payload onto the stack, we'll create our node. If this dot top is equal to null, this dot top is equal to n, else we're going to say n dot set next node equal to top, and then this dot top is equal to n. Make sense? Public int pop, int value to return will be equal to top dot, well here, I won't even throw in I'll throw an exception. What the heck? Throws exception if this dot top is equal to null. Throw new exception empty stack. Try more. Else int val to return is equal to this dot top dot get payload. So that's the value we're ultimately going to return. And then we're going to set this dot top equal to this dot top dot get next node. Okay? And then return val to return. So that's pop. So get the payload from the first dude in the list, assuming there is something in the stack, rather. So get the payload from the first thing in the stack, set top equal to the first, equal to top's next node, which could be null if it's only the one list. Otherwise, it's the new top of the list. And then return that val. Make sense? All right, then peak is a lot like pop. We'll say the empty stack error again, val to return. Actually, we don't even need to say val to return. You can, I guess, but that wouldn't be, I mean, if you did that, that's fine. I won't take off points, but peak should still return the value. It just doesn't remove it. Because the idea of peak, you want to use, you want it to be functional. So we want to be able to ask the stack, give me the value at the front, but don't remove it. That way you have it, you can do something with it if necessary, or ask questions regarding it as opposed to just spitting it to the screen, right? All right, so we'll just return the payload from the top, but that's all we've done, is we returned the payload from the top. We didn't disconnect it. We didn't do anything else. We just kind of let you peek at it. Make sense? All right, so that's stack. And then we can go ahead and test that. Stack, the stack, is equal to a new stack. And then we'll say this dot, I'm sorry, the stack dot push 5 4 3 2 1. So we pushed on the 5, then we pushed a 4 on top of that, then we pushed a 3 on top of that, we pushed a 2 on top of that, we pushed a 1 on top of that. So that should be 1, 2, 3, 4, 5, right? Now we want to go ahead and just make sure that those things actually got put onto the stack. So we're going to just say try This will be a nice, quick way for us to prove our stack works. Well, actually, heck, we won't even be, we'll just be lazy. Even better. So we'll just create an infinite loop here that just keeps popping stuff off the stack until an exception is thrown. Then we'll throw the exception. At least we'll know we got our 1, 2, 3, 4, 5. Okay, this will show us that our stack is working. 1, 2, 3, 4, 5. Okay, and this is system error. That's why it's out of order, but that doesn't mean that this happened before these other ones happened. 2 different output streams. This is system.err. All the rest of these are system.out. So 1, 2, 3, 4, 5 shows us that the stuff got put into the stack in the correct order, because when we pushed them on, we pushed on a 5, then a 4 on top of that, then a 3 on top of that, 2, then a 1. So when we popped it off, popped off the 1, then popped off the 2, then popped off the 3. Make sense? All right, so that's our stack. And then we can go ahead and we can do a system.out.println the stack.peak. And that should show us the 1. Make sense? All right, so fully functional stack as far as we're concerned here. Questions about that from a homework perspective? Well, I guess from any perspective. How did the homework go? Easy?
Yeah. I noticed a few changes I had to make after this. I had a lot of extra crap because I was reusing code.
Yeah. So notice this stack is substantially simpler than a full-blooded can do everything linked list. All right. So let's go ahead and let's now use our stack for something interesting. What are some things that we might, oh, well, here, let's go this route. How many of you have ever used a Hewlett-Packard calculator?
What?
Or a calculator that supports reverse Polish notation?
What's Hewlett Packard? Is that like HP?
HP. Okay.
They make calculators?
Yeah.
I thought that was only Texas Instruments.
Mm-mm.
They make business ones.
They make a lot of business ones, but when I was younger, I actually had a Hewlett-Packard graphing calculator. That was what the cool kid. Back then, TI was the PC of graphing calculators. HP graphing calculators, they were the Mac of the calculators. You know, the elitists used those and thought they were better. Okay? And the thing is, those calculators use what's called reverse Polish notation. This is us, right?
No, we're 300.
Yeah, but we just continued on from last semester.
Oh. Oh. I suppose it is then.
All right, so reverse Polish. Okay, this is a political movement. So
Started in 1982. Oh.
We just started today, so it's
I thought you were talking history, German.
No.
Hitler.
uses a stack for inputting 2 T's? Yeah, whatever. And processing math expressions. It's fine.
Yours not working today?
Huh? Well, they usually aren't.
You could use a stack and put a full deck of cards in there and play blackjack.
Yeah. See, even with bad fingers, I still just wrote a whole stack data structure in like 4 minutes.
It'll take me much longer.
But I taught it during it.
I only have one arm.
I had a broken coffee cup. Okay, so reverse Polish uses a stack for inputting and processing math expressions. So the idea is you want to think about your calculator as a stack. So let's say you want to add 5 plus 4. The way reverse Polish works, well, on a TI calculator, you would say 5 plus 4. And then press enter, and it would give you your answer, correct?
Mm-hmm.
Reverse Polish, you would say 5, 4, plus. Okay? And then that plus would trigger the stack to do the math. So operators trigger the stack to do the math. So you would push a 5 onto the stack. Then you push a 4 onto the stack. Then you'd push a plus onto the stack. And what that would do is it would actually result in the 9. Go ahead.
Would it only add the previous 2, or if you put like 5, 4, 6?
It would only add the previous 2. Yeah, you would still need like a function to do like sums and stuff like that. But yeah, so you just changed your mindset a little bit on how you did math. So everything was done in terms of the stack data structure. Now, since, well, evidence would say since I'm guessing nobody in here had heard of reverse Polish. You had heard of it before? Okay, so most of us, it's a foreign concept. So clearly in the calculator world, reverse Polish is kind of lost out. Now, having said that, going back to your question, let's say you had a whole bunch of numbers on there. You could keep doing pluses after that, and it would keep taking the last thing on the stack, because what it would do is when you did the 5, 4 plus, it would pop the plus, pop the 5, pop the 4, and then push the answer back onto the stack. So you get the 9. So if you had a bunch of stuff on the stack like 5, 4, 3, 2, and then you did plus, it would pop the plus, pop the 2, pop the 3, push a 5. Then you could say plus, it would pop the plus, pop the 5, pop the 4, push the 9. Like that. So you could take advantage of what you knew was already on the stack, which I think is maybe sort of what you were getting at, but you were thinking maybe I just put the plus and just flip through all of them. Okay, so it always pushed the answer back onto the stack. That makes sense? Okay, now if you remember way back, we had made a process expression type of function. At some point where you took in a string that was like 1 plus 2 minus 3, blah, 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 and you had to like process that. That guy, we split it on the operators and did the math, all that crap. That was last semester sometime. Well, now we're going to kind of make a calculator, but we're going to start off with just a functional thing where it's going to give us a prompt that we can work with by putting in numbers, and numbers will get pushed onto the stack, and then we can put in operators, and those will get popped off the stack. And then we'll also give it a command that will show us the current state of the stack. Make sense? So we're going to write a simple calculator. So we're going to start off by creating a new class. And we're going to call this guy RP calculator. Here, let's do RP calc. Reverse Polish calculator.
I feel bad because I named mine the full reverse Polish.
That's fine. What was I talking about? Oh, that's right. It's not only the fingers that aren't working. The engine's running, but nobody's behind the wheel. So we're going to have a private stack. We'll call this the stack, because I like naming variables like that. When we first create our calculator, we're going to have a constructor, public rpcalc. Take no parameters, and we'll say this dot the stack is equal to new stack. Okay? And then we'll go ahead and we're going to have a, let's just have a method that kind of starts the prompt. So we'll say public void let's just call it on. Turn the calculator on. All right. And we want to be able to give a prompt here. So the prompt is going to ask us for our next number, but we'll just give it kind of like a little arrow looking prompt. So we're going to say while true, because we're going to give a prompt forever until something else happens. While true, system.out dot print. That's what our prompt looks like in our math world here. Make sense? So we'll give them a prompt. Then we want to be able to read in from the user what they type in at the prompt. So we're going to have our scanner. So I'm going to create a scanner up here. I'm going to import java.util scanner. All right, so now we have the ability to read something in from system.in. We'll print out our, so forever, basically what this while loop says. Eventually we're going to have a break in there to bust us out of that loop, but I'll just say forever. We are going to print out a prompt and then read in whatever the user types. Okay? And for right now, just to prove it's working, we're going to just spit out whatever they typed in. So we're just going to have an infinite prompt that shows them a prompt, we type something in, press enter, and it just spits out what we typed in, proving it received it. Then it'll prompt us again. Make sense? That's all this guy does right now. We'll start processing some stuff here in a few minutes. So we'll go back into driver, get rid of our stack from out here. We'll go ahead and create an instance, our rpcalc. The calc is equal to rpcalc. And then we'll say the calc dot on. That tells our calculator to turn on and shows us the prompt, right? So we'll go ahead and hit play, and now we have a prompt. So if I type in 5, it shows us the 5. If I type in 3, did I do a println or a print for my prompt? Println? That doesn't look very professional. We want to print. Oh, so much better. 5, 3, 2, plus sign, whatever. So we're showing it's reading it in, right? Okay. So now what we want to do is when we read something in, if it's a number, we're going to push it onto the stack. That's what we do with numbers. Okay? So we need to determine if something is a number. How can we do that? I'm reading in some string. That string might be, let's say our command for quitting is quit. So let's just quickly put that functionality in. So we can say if val dot equals, let's do equals ignore case, quit. Ooh. We'll break out of this loop. Okay. Now, why did I have to say val dot equals here instead of just saying val equal equal quit? Why couldn't I say this? Val equal equal. That's going to compare the pointers. This is going to say the pointer for val is one memory address. Is it the same memory address as this guy? If I want to compare the contents of the string, I have to use the string's built-in method for comparing the contents of the string. And equals ignore case compares them without, compares them while ignoring case. So I can type in quit in uppercase, lowercase, a little bit of both, whatever. All right, so now I have a way of breaking out. So I got my, I can do, and then I can type in quit, and it's no longer going to prompt me. We broke out of the loop. Okay? So now we're handling that. So if I type in quit, let's just break out of it. Else if. How do I detect if val, what I just read in, is a number? It's a string. We'll be reading it in as a string. And I want to know, is this string a number? Using what's in your toolbox right now. Go ahead.
Could you parse it and then have something in there to check like if it's
If it can parse.
Okay. So tell me a little bit more about that. You're going down a decent path. So you want me to use parseInt, and then you said have something in there to check if it's a number. Oh,
not a letter or something.
okay. Well, if I call parseInt, and you're saying integer.parseInt? If I call parseInt on the word Bob, what will happen?
Or return.
You can have a Boolean saying if it's true or false.
What does parseInt return? ParseInt returns an int. It's not a Boolean. How do we know that a string is a number, a representation of a number? What would be true about that string?
The only characters in that string would be the number value characters.
Okay, only characters would be number value characters, so digits. What about pluses and minuses, though? Could we have negative 123 stored in a string? Is that a number? It is. But the negative has to come where? Very beginning. We can't have just minus signs strewn throughout our number, correct? Right, so how can we do this? At the very least, you should be able to give me the old way of doing this. If we write our own method. If you were to write a method to check to see if a value was a number, how might you write it? So I'm going to write a method here.
You can check if just the first bucket on it is
Private Boolean is number, takes a string s as a parameter, and this guy should return true if s is a number and false otherwise.
So you have to go through every number.
I have to go through every bucket of that string. That's my normal for loop, right? For int I is equal to 0, I is less than s dot length,
well, since
I plus plus. That'll go through every character in S. We'll take I on a journey for every index in S, and now I have to do something at each place.
wouldn't we only need to check the first bucket in each one because of how the stack works? So if we enter in a
Oh, forget about stack.
Oh.
I am passing in a string to a method called isNumber. This method's job is to return true if whatever's in S is a number, false otherwise. This has nothing to do with stacks right now. We're writing this method. Don't all speak at once. This is 250 stuff we're looking at right now. How do we detect if something is a digit, 0 through 9? Huh? Okay, so we can create a string. We can call it map if we want to. So those are all the legal digits, right? So if I have a character and I want to know if I have the character 1 and I want to know if this guy is a digit, how can I use my string name map to do that? So char C is equal to a 1. I want to know, how do I check to see if C is a legal digit?
You have another for loop going through the string.
Okay, I don't want to write another for loop. We know a better trick than that from 250. Go ahead.
Like while it's not equal to that number.
I don't want to use a while loop either. I want no loops. No loops. I want to use our smart trick we learned in 250. Like week 3 or 4 of 250.
Do you use compare to?
We never learned compare to 250, did we?
Okay,
No, that we probably did. Well, the short answer is no, we can't. The second reason is, so now that you brought it up, what's compare to do? compare strings lexigraphically, whether one string comes before another string. So we used it to alphabetically sort strings. That's how we were using it. Wasn't that the portion of your notes it was in? You were doing sorting stuff? It had to be.
Yeah, I think so.
But make sure if you have it in your notes that you have lexigraphically somewhere in there. It's important as opposed to alphabetically, because lexigraphically will treat upper and lowercase letters differently. So can't use compare to. We had a trick that we used much more often than that.
S dot I.
Just S dot I?
Find it at the index.
Okay,
Which index?
index of.
That's not
Index of. That's what it is.
Okay,
I equal to
so if map dot index of C, what will this guy return if C holds a number, a digit, 0 through 9? Okay, it'll return something that's not -1, right? Index of, the power of index of for us is that it returns -1 if it is not found. So if this guy returns something that is not -1, it's a digit. Else, it's not a digit. Remember our index of trick? Okay, all of you should have somewhere a document that lists all of the magic tricks that you have in your programming toolbox. That way, when I ask questions like this, you can go back to and say, oh, well, any of these useful? Just like if you had something broken around the house and you ran out to the garage and took your toolbox and looked at it and see, okay, what do I have to try to solve this problem? And for a guy, as long as it's a screwdriver, a hammer, and some duct tape, we could probably work something out,
So,
right?
what about how I fixed your massage chair?
Well, you need more than duct tape for that. All right, so
I feel like I needed an engineering degree at one point.
So now, that determines if a single char is a digit, is an integer. I want to determine whether this entire string is a number.
Well, when you go through each part of the string,
Okay, so this goes through all the string.
yeah, each part you can check each letter in the string, right?
Mm-hmm.
So,
So if map dot index of I, or I'm sorry, index of s dot char at I, if that guy is not equal to a -1, that means it's a number. What if it is equal to -1? It means it's not a number. If it's not a number, what do? Return false? This guy must not be a number. The string holds something that's non-numeric, not a number. Otherwise, we just keep cooking. What about it starting with a plus or minus? Or you want to do it in?
Within the if, within the for loop.
Okay.
There's another if statement that says if I is 0. Then
Okay.
If I is 0, then it will also result plus or minus. That's what it's about.
Okay. We only need to check bucket 0 once though, right? So couldn't we, outside of here, say something like if s dot char at 0 is equivalent to a plus, or s dot char at 0 is equivalent to a minus. If either one of those things is true, we're going to let this guy slide so far, right? But we know we don't need to check bucket 0 any longer. So we'll start at 1. One thing we could do is we could just say s is equal to s dot substring 1. Just modify s so that it's everything from bucket 1 on. That make sense? So in the event that S started with either a plus or a minus sign, we'll go ahead and say, okay, you're good for now. And notice, this guy is not turning it into a number. This guy's just detecting whether it's a legal number. So if it started with a plus or a minus, we'll say, okay, you're fine, but I know if I leave things alone, my loop will incorrectly fail on you the very first time through. So what I'll go ahead and do is change S to be S.substring from bucket 1 to the end. So I'm basically cutting off the plus or the minus. We'll ignore that in the rest of my check because I've already passed you on that guy. Those are legitimate first characters for a string. It will fail in my for loop, so I'll go ahead and cut those off and not check those. That doesn't mean the guy's automatically a number. It just means it's a string that started with either a plus or a minus. Make sense? We want this guy to fail in all other circumstances. Okay? If we're still kicking down here, return true. Go ahead.
In the for loop, would you then have to set I equal to 1? Because you're at 1 already, you don't want to go 1 with that string before you.
No, we don't, because we made our string 1 shorter.
Okay.
Yeah. What he was suggesting, what you're suggesting here, is instead of doctoring my string, starting this off at 1. But I'd only want to start it off at 1 if I was looking at a plus or minus. So instead, what I'm saying is if I'm looking at a plus or minus, let's just make my string 1 bucket shorter by overwriting it with itself minus bucket 0. That makes sense? So now the new bucket 0 is the old bucket 1. Okay? So will this detect numbers? Should. All right. So let's say we don't want to do it that way.
Get rid of all of it.
Well, we can. I'll just do it is number 2. So that is a legitimate way of detecting, see if something is a number, and it'll work fine. Is number is not something that's computationally expensive, so it'll be fast. No harm, no foul. But we have some newer tools that might allow us to do this in substantially shorter lines of code. More easily. More better, if you will. Something we've learned this semester. Something we've learned the last couple weeks. Want a hint? How could we use exception handling? Randy started us off in a pretty good place by saying, couldn't we use %?
So you try the %, check the exception.
Try integer dot %s catch exception e return false. Otherwise return true. Make sense?
You're returning false twice?
Oh, I'm sorry. I said return true, didn't I?
Yeah.
All right. See? So we'll go ahead and just try to turn it into an integer. I'm not even storing it anywhere. I'm not going to use it. I'm just going to try to turn it into an integer. If it works, great. I won't have an exception, and I'll just return true. Made it through the minefield. If it doesn't work, I'll catch the exception. I'm not even going to look at the exception. I'm just going to say, must not be a number because this guy failed. Go ahead.
But what about the plus or the minus?
%. Will support pluses and minuses. Already. We don't care how it does it. We just know it works. Yeah, if I pass a string -127 to integer.parseInt, it'll give me the number -127. And I'm pretty positive if I pass +127, it'll give me the number 127. Suppose I should check that real quick. But I'm fairly certain. System.out.println. Just get rid of this real quick. Oh, maybe my driver. Oh, my same problem as before? Is it?
Yeah, it was giving it an error.
Okay, so it must not support positives. So we can say if we're going to say a number is whatever integer.parseInt supports as a number, then negative works but positive doesn't, which makes sense.
We shouldn't put positive.
Yeah, you know, if we want the positive version of 127, we just say 127. Otherwise, we say negative 127. So this will handle it in a way that's consistent with how Java handles everything else. Does that make sense? So we're leveraging our ability to do tries and catches rather than having to loop through and do it ourselves. We know that integer.parseInt is probably doing some interesting stuff, probably some stuff similar to what we're doing down here, right? I mean, it's doing loopy stuff. So it's not like we're avoiding the complexity of loops. We just didn't have to write it ourselves. So we will try to turn S into a number. If something goes south, must not be a number. If something doesn't go south, well, hey, it worked. Must be a number. Make sense? So this would maybe be our more modern way of doing this for us, because now we have we have exception handling in our toolbox. We happen to know that integer.parseInt can throw an exception, so now we can use isNumber to solve this problem. So we'll call that isNumber, and we'll dump old school isNumber. Make sense? All right. We actually could put the return true in here, but it's fine where it's at. All right. So back to our prompt. If we type in a quit break, else if this dot is number val, we don't need to say equal to true. That's redundant, right?
No.
If this guy returns true, it would be equal to true.
Yeah.
What's a Boolean expression? Any expression that boils down to a single value of true or false. So saying equal true here is not incorrect. But if this guy boils down to true, we're asking the question, is true equal to true, which is true. If this guy boils down to false, we're saying is false equal to true, which is false. So you might as well just use the true or false that came out of this guy.
Like be redundant.
Okay? So if val is a number, what do we do with numbers? Push them onto the stack, right? So this dot the stack dot push, and this guy takes an int payload, so we'll say integer dot parseInt val. So now we have the integer version of that guy on the stack. So if it's not quit, and it's not a number, it could be a operator. And we're going to give an error for anything that's non-operator, right? So right now, our acceptable inputs, are quit, a number, and an operator. So we need to probably have a string for our operators. Plus, minus, times, divide. Now, we could write it this way, but what I might do just for code readability perspective, I might actually put that inside of a method. Private Boolean is operator. This guy takes a string s as a parameter. We have our string map is equal to.
If you have a negative, would that use it or no?
Well, you wouldn't have a negative for a plus sign.
No, but for like a minus sign.
Oh, no, because it would fail the isNumber test.
Okay.
Because if we call integer.parseInt on just the minus sign, it's going to scream at us.
Okay.
All right, so map is plus, minus, times, divide. Those are our operators. We will return map dot index of. Now notice, we maybe haven't seen this variant before. There are multiple versions of index of. There's actually 4. What's it called when we have the same method, a method with the same name but a different number and or types of parameters? Polymorphism. So here's a second version of index of that actually takes a string as a parameter instead of a char. So I can go ahead and just pass it the string I got. You hope it's just a string with one element in it. Okay, but I'll pass it the string I got, s. So if map.index of is not equal to -1, this guy will return true. Right? So if I have the string plus sign, so I have that guy, it's going to return bucket 0. I found the string plus at bucket 0 of this guy. But if I pass in the question mark, it's going to say that's not found in here. It'll return a -1. So this boils down to true if whatever I pass in ultimately gives me something that's not a -1, which means it was found in here. All right. The one weakness to doing it this way is this. If I pass in plus minus, this is not a legitimate operator, yet it would pass this test. That makes sense? Okay, so really we need to find it in here and s dot length must be equal to 1. Both of those things need to be true. Okay, it must be in map, and the length has to be 1 of that string to prevent things like this from flying under the radar. If somebody happened to know the order that we had our elements in our string, because plus, or here, minus plus wouldn't work. That would fail because minus plus is not found in here. A minus and a plus are found in here, but the string order of minus plus is not found. Does that make sense? So index of would return a -1 for this string. Doesn't find it in there. So we'll save ourselves by saying as long as the length is 1 and it's found in map, must be a single operator. Okay? So that means it would also fail on things like plus space. That has a length of 2.
Couldn't you just make them input a char or no?
Well, they are inputting a char, but we're reading it in as a string. Yeah, I mean, so we're relying on them to type in appropriate, not put extra spaces in and stuff like that. But we could trim whatever they put in. You know, that way if they did hit plus and put a space bar, wouldn't be the end of the world. So we could do that. So we could. It actually wouldn't hurt to do that anyways. So this method still works on its own. Even if we trim it, that means they could put in something like this at the command line. But if we trim it, it would get sent to this method like that. It would have all the leading and trailing spaces removed. But just from an is operator perspective, if we pass in a string s, if it's found somewhere in there and it had a length of 1, we're going to return true. Otherwise, we're returning false. All right. So right here, what I'll do is when I read in val, I'll say input.nextLine.trim. That'll just take off any extra spaces they put before or after. to help us deal with user error. So if the user types in plus, then a bunch of spaces, and then hits enter, that'll get read and it's just the string plus.
You can trim the string.
Huh?
Trim the string.
Right. All right, that makes sense? So I'll read in val, remove all the leading spaces and trailing spaces. It doesn't remove spaces from the middle. So that means it would still fail on things like plus space minus, because it would, and then I put a bunch of spaces there, it would take these spaces out, but it would leave the space in the middle and give us a string that looks like that. If it's quit, break. If it's a number, push it onto the stack. If it's an operator, we're going to do something else. Otherwise, it's not one of our legal inputs. Not one of our legal inputs. So we will say system.err.println. Well, let's actually do system.out.println. That way it shows up in the right order, guaranteed. System.out.println, illegal input. And then it'll loop back up in our loop and give them a new prompt. So if they put anything other than quit, a number, or an operator, we'll just do nothing, give them a little warning message, and loop back around and let them do it again. Now, if we are dealing with an operator, though, what do we want to do? All numbers got put onto the stack. If we are dealing with an operator, how do we want to handle it?
Like you want to peek at it and then add it to integer and then.
Well, we're after, so far, I've looked at an operator, but have I pushed the operator onto the stack? It's not on the stack yet. Do I need to even put it on the stack? You know, why put it on the stack just to pop it right back off? I have it. I have the operator in my hand. And I know if I have the operator, that means, unless the person's using the stack incorrectly, I must have at least two numbers, right? So I need to pop those two numbers, then perform the math. Okay, so I'm going to say int num1 is equal to this dot the stack dot pop. Int num2 is equal to this dot the stack dot pop. Oh, this guy pop potentially throws an exception, so we'll make our on throw an exception, just as laziness. So that'll pass the buck. So we get our two numbers. Then if val dot equals a plus, we're going to do one thing. Else if it's a minus, do something else. Else if, else if. So plus, minus, times, divide. Okay, any of those? What are we going to do? We're going to say this dot, the stack dot, push. What are we pushing? Num1 plus num2, if it's addition. Num1 minus num2. Okay, now something to consider. If we say 5, 4 minus, what should the result be?
Oh, no, 1. It is -1.
It's -1. Okay, so 5 push, 4 push, minus should do the math 4 minus 5. Make sense? So it'll be a -1, not a +1. So what we've done here is correct. We don't have to do anything special. Just understand the expected result. Okay? Else if it's multiplication, we will multiply them. Else if we'll divide them. And then we'll push the result back onto the stack. Make sense? Okay, now, we probably want to give ourselves an additional command up here. Maybe show. Else if val dot equals ignore case show, we might say that command means what? Show the contents of the stack? All right, well, how do we do that? I need to display my stack in its current order. So if I have 5, 4 in my stack and I want to display it, I should see it 5, 4 to the screen.
Go through for loop. No while.
Well, if I pop it off in order, I'm going to get 4, 5. Usually when you're dealing with a reverse Polish calculator, you see your stack upside down. Because you're looking at the screen here. And if you have 5 and 4 on your stack, where 4 is the top of the stack, so 4 and 5 on your stack, so that means you push to 5, then you push to 4 on top of that. You would see the 4 at the bottom, the 5 above that. So you actually view your stack as if it's upside down. That's just convenience, right? Because you're using the calculator, and if you have 500 things on your stack, you want to see the top several on your screen, because the other things are going to be scrolled way off the screen. That make sense? So how do I display a stack upside down?
Create a new stack and then pop the old one onto the new one.
Okay, so he wants to create a temporary stack. So stack temp is equal to new stack. And then you want to go through, and he's going to take the 4 and the 5. Here, let's actually draw a picture for this one. So we have our 5. We push that onto the stack. Then we have our 4. We push that onto the stack. So right now, this is the top of our stack. We'd like to display our stack 5, 4. So what he wants to do is he wants to create a second stack that pops from this one and pushes it onto this one. Then he wants to take that other stack and pop. So when I popped it, this guy came off. So here, well, you should only have one of these. So I popped, then pushed. Then I popped, then pushed. So now I've just built my stack upside down. That make sense? Now I can go through and pop, print, push. Pop, print, push. Which leaves my stack in its original order, intact. But I was able to go through it backwards. So I need to pop all the elements of my stack over to another stack, and then push them back onto the original, but print in the middle. That make sense? One thing I'm going to do to give me a little convenience method is in my stack, I'm going to add another method. Public Boolean is empty. I want to be able to detect if my stack is currently empty. I want to be able to ask that question. I'm going to return this dot top equal to null. That's all that guy does. If top is null, that means your stack is empty, which means this guy should return true. Okay? So now inside of RPCalc, I created my stack temp. I'm going to say while this dot the stack is not empty. As long as my current stack is not empty, we're going to say temp dot push this dot the stack dot pop. So that'll build it upside down. So that's this picture right here. My original stack, is this guy empty? Nope. Pop, push. Is this guy empty? Nope. Pop, push. Is this guy empty? Yes. I'm done. So now I've emptied out the stack, filled up temp. Make sense? The stack is actually empty. I have physically removed stuff from the stack through pop, but I've pushed them onto temp to preserve them. Now I'll say while temp dot empty, while not temp dot is empty, so as long as temp is not empty, what am I going to do? I'm going to say int val. Ooh, no, we're fine. We're fine. Int val is equal to temp dot pop. Then I'll say system. Oh, I already have a val in here. So temp int num is equal to temp dot pop. System dot out dot println num. Then this dot the stack dot push num. So when all is said and done, the show command will go through, pop everything off the stack, and then push it onto the other stack, then pop it off the other stack, displaying each time before it pushes it onto the next stack, the original stack. Make sense? All right, so now if I run this, get my calculator back up here. I'll do a 5, I'll do a 4, I'll do a 3, I'll do a 2, I'll do a 1. Then I'll do a show. 5, 4, 3, 2, 1. Shows me my stack upside down. Now I can do a plus, and the plus should add 2 and 1 together, giving me a 3, pushing the 3 back onto the stack. So now I can do a show. There's my 3 on the stack. I can do a plus again, which should pop the 3 and the 3, giving me a 6, pushing that back onto the stack. I do a show. There's my 6. Now I can do a multiplication. 6 times 4. So what, 24? Okay, so that's going to pop these 2 off there, give me a 24, push it back on, show, there's 24. Yours isn't working?
No.
Okay, lastly, I could do a divide, show, it gives me the 4, integer division. Make sense?
So would that be dividing by there?
That's 24 divided by 5.
Okay.
Integer division, no remainder. Now our stack has one thing on it. And we might want to say this inside of our code. We might want to go into RPCalc and do something like in our on, if we type show, before we create the new stack, we might say if this dot the stack dot is empty, just do a system dot out dot println empty stack, something like that, and then maybe do a continue. Remember, continue just doesn't break us out of the loop, it just runs through the next copy of the loop. Okay, so by saying continue here, it'll just drop to the very end of the loop, all the way down here, and then spin back up to the beginning of the while loop. Because that's all we should do in that case. If the stack is empty, I don't need to do any popping and stuff. Instead, I just want to display to the screen empty stack, and then go on, show them another prompt. Okay? So by doing that, now I can go in and I can type show right off the beginning. I get empty stack and it shows me another prompt. And I can do 5 and 4 and then plus and then show. It gives me the 9. Make sense? So fully functional calculator. All right, for homework, I want you to get this working. I'll put it up on GitHub for you. I want you to add one function. Sum. Add the sum function. It's his fault. So now you should be able to type in, if I do 5, 4, 6, 7, 9, so that's what my stack currently looks like. And then I type in sum, it should go through, add all of these up.
Wait a second. Why is there 9 at the top?
Because that was left over from my original math, the 5 and 4.
Oh, got it.
Yeah. We learn reverse Polish. Durr. All right, so this is what my stack currently looks like. If I type in sum and press enter, it should sum all these up, pushing the result back onto the stack.
What's a calculator? Don't we need a reset button to
Huh?
clear out the stack?
Well, you can do that if you want, but I'm only making you write sum. That make sense? Questions, comments, concerns, bribes?
People are like,
All right, so I'll put this up on GitHub, give you the link with the homework so you can download it so yours will stop sucking. And then you need to add the sum function to it. All right, so pretty cool. Functional HP calculator during class?
Not cool.
Not cool.
Texas Instruments.
Well, yeah, they did lose out. I don't think you can buy an HP graphic calculator anymore. They might have some
As an
street. They might have some street value on eBay. I think I had a 48GX HP graphic calculator, 48GX. I had a. I was the cool kid. I had a 128 kilobyte add-on card
whoa,
for extra memory.
whoa. I think
Kilobytes.
mine's got like 4 gigs. That's got some weird things.
Because I wrote software on them.
Store on there?
I wrote software.
Oh.
I was in